Welcome back to linear algebra. Let's jump into Anki. What is the size of an augmented matrix of a linear system of m equations and n unknowns? M by n? No. Augmented matrix. M by n plus 1. What is the trace of a square matrix and how is it denoted? Trace is the sum of the entries in the main diagonal of a square matrix. It's denoted by basically the power of capital T. No, it's not. That's transpose. Denoted TR, parenthesis A. Sum of entries in the main, it's like a function looking thing. What is a row matrix? It's a row matrix is a matrix that only has one row. Okay. What is a column matrix? Column matrix is a matrix that only has one column. All right. There we go. All right, good. All right. So we spent the whole day yesterday working on this problem. I think we missed. Or I missed. Did I grade the rest of the stuff? 40? Huh. Let's see a check mark. 36? Did we get 40 right? You just jumped to 44, huh? So 44, to recap, we had a good proof for n greater than or equal to 0, but since it's a matrix, we have to show for powers less than 0, integers that are less than 0, so negative powers. So it has to be a different level of proof. Do we finish this? Doesn't look like it. All right, I'll be back in a second once I'm done with this. All right, there it is. We're done. So I just had to finish up that this m distributes, which was proven above. I really should have actually done one more step. -1 times m, but that's fine. And then it's just going to be substitution again. So that's that. That was a proof. We're going to grade one more problem, then I'll be back to continue working on more problems. Oh, we got this one right, so that's pretty cool. We got that one right. Simplifying it, basically a matrix expression. All right. So I'm gonna continue working on problems, and I'll be back to recall what I did in a little bit. Okay. We went back and did one of these problems from 1.2. Basically gave me this matrix with stars out that can be any real number, and it says, is this matrix consistent, inconsistent, and if it's consistent, does it have one solution or infinitely many solutions? Just based on what I think, my intuition and some of these explanations, I say consistent because we see that in the bottom row, when it's in row echelon form, that 1 equals 1. So it's not no solutions. That would be no solutions if that was 0. But this is a valid solution. And since we have the same number of leading variables or equations as the number of rows, we know that just through any way these can get eliminated. No matter what these numbers are above, they'll just get eliminated. And that we'll have one real solution for each of these, given that we know these leading ones in row echelon form. This is defined, the number of rows equals the number of equations. So consistent, one unique solution. Pretty confident on that. Then this next one was like show again. It wasn't prove, it was just show that no, that's not equals. If A equals A, B, C, D, that this equation is satisfied. A squared minus A plus D times A plus AD minus BC times I. So kind of just a little bit of practice on matrix manipulation and scalars and stuff. So A squared, that's simple. and just take the two of them, multiply them together. This is this, and then we're going to minus that by basically you're just taking this is essentially a scalar, so you're just going to put that in, times that by every entry of A, and then you can distribute. Same thing with this for I. You can just, this is a scalar, you multiply this by 1 in the corners in the main diagonal. So eventually you'll get here, this is A squared, this is the A minus D times A. You distribute out, and you start to cancel a lot of stuff, and you end up with BC minus AD here in these two positions, 0, 0, plus, and then this is I multiplied both of these ones by AD minus BC, so good sign that it all cancels out, and there you go, it's 0. And then we're doing another proof. This is a proof. I'm trying a little bit different, not writing so much, a little bit more succinct. So what we're trying to prove is if matrices A, B, and C are the sizes, are of sizes that are the sums are defined, essentially they're the same size, then this is true. So basically what I'm trying to do here is say the entries of B plus C will be Bij plus Cij. Similarly, this A plus B, or B plus C plus A, will be basically this, but with these are the parentheses, and then A is on the outside, Aij. And then you're going to show that for this too, and then say that the entries are equal due to the associative property of addition, and then say that the matrix are equal due to the definition of equal matrices being the same size, which they have to be because they're the sum is defined, and the entries equal, which has to be because we just shown it that, and the associative property of addition. So all right, that's it for today. Talk to you tomorrow. See ya.